right, so we have a twice differentiable function. We know that f prime of 1 is 0. That's going to come in to play. So anytime they tell you that, it's usually not extra information. You're going to need it at some point. And then we want to type in the second derivative into y1. Just do a quick check on your calculator to make sure that you are in radian mode. If for some reason you're in degree mode, it messes this up. But radian mode is the default mode, so there's a good chance that you are in radian mode. Make sure I didn't do something wrong. All right, and then we're only looking at this graph whenever x is between -1 and 3. So I would recommend that you go to your window and you change your x min to -1 and your x max to 3. Trig graphs don't typically get super tall. So I'm just going to go -5 to 5 on my y. We may need to change that. I think it's going to be okay. Let's see. Yeah, that's fine. All right, so the question is, A is on what open intervals, which is not what we're used to doing. We're used to doing the brackets. I don't know how picky they're going to be about the brackets versus parentheses, but if it says open intervals, we're going to do parentheses here. So on what open intervals contained between x is -1 and 3 is the graph of f concave up, and give the reason. So is this graph f? Absolutely not. This is the second derivative. If we want concave up, what do we want for the second derivative? Positive. So we're positive 2 little sections here and here. And so we're going to calculate the zeros, because what we want to find is where it's crossing over. So we're going to calculate the zeros. So second trace 0, and then we're going to hit enter on the left side of one of the zeros, and enter on the right. Okay, I'm actually going to start writing the answer because I don't want to lose that number. All right, so we would start writing. What? I'll get my stuff together one day. Okay, we're going to start writing that f is concave up. On, and then we are going to try to remember to do parentheses if it says open intervals. And so it starts off at that number accurate to 3 decimal places. All right, and then we'll do it again.
The 0.
Yeah, the next 0, because we have to give an interval from 1 0 to the next 0. All right.
Instead of and, can you do
Yes, you can do the U. That's what I wrote on my paper. The U is perfect. All right, one more 0 to 5. All right, am I gonna say to infinity?
No.
Good, I I'm not. I don't really know what's happening after 3, but we're only going to 3. So we would say to 3. And we have to give a reason. So what is the reason?
Because F double prime is positive.
Absolutely. Bless you. Bless you.
Thank
Bless you. So you can say F double prime is positive. You can say F double prime is greater than 0. Either one, they mean, obviously, they mean the same thing. All right, I need to pass back your quizzes. A lot of people missed this question on the quiz, and it was using the second derivative test. So we don't know anything except that f prime of 1 is 0. So what does it mean that that 1 is? A potential relative maximum or a critical number. And we have the second derivative. So if we're deciding if 1 is a relative maximum or neither, we have to use the second derivative test. We don't have any other options with the information that we're given. So what do I need from the second derivative? If it's positive or negative at 1. So somewhere on your paper, I would recommend that you write f double prime of 1. And then you find what that is. There's lots and lots of ways to find what that is. My favorite way is to do, I did this in pre-calculus today, do y, it's, that second derivative is y1, and then just put 1 in parentheses. All right. And I think they might actually want to see that number.
Like the whole thing?
No, 3 decimal places.
Oh.
The other thing you can do, like some people like to just look at the table, and that's fine. Oh, the table doesn't give you 3 decimal places, or my table doesn't, so maybe that's not fine. Now this asks you to justify, so when you justify, you have to use a rule or a definition or a test. In this case, it's going to be a test. So you would say something like, by the second derivative test, or you could say that at the end if you've already started writing, it's okay. F has a relative, what do y'all think? Yes. So it's a it's a potential relative max or min. If the second derivative is negative, are we concave up or down? Down, which creates a maximum. That's what I do in my head. You all don't, you can have it memorized if you want to, but that thought process will always get you to the right answer. All right, there's 2 things we want to list because the second derivative test, there's kind of 2 conditions. One of them is that f prime of 1 is 0, that is a critical number. And then the second part for a relative maximum, f double prime of 1 is negative or less than 0. Now on the quiz, the one that people missed, it was tricky because you had this table and it looked like you'd use the first derivative test, but you actually had to do the second derivative test. Because on the table, you didn't know what happened in between the numbers. And so make sure you're careful on that. Okay, and then C just asks, does the graph of f have a point of inflection at 0? So let's go back to the graph of the second derivative. What has to happen on the second derivative for there to be a point of inflection? Changes sign. Does that happen at 0? It doesn't. So we're going to say no. Just say no. F does not have a point of inflection. At x equals 0 because f double prime does not change sign. Let's be a little more specific, sorry. Does not change sign at x equals 0. Or you can say there. It does change sign other places, so you have to be careful. At that point, that's fine. Okay. Now, this number 2, I feel like, is a little more difficult than the number 2 that you're going to have on your test. So this will also help prepare you for other things that are maybe on the multiple choice, so it's fine. All right, so we have the graph of G, and then we have a whole different function that has to do with f, and what we know is that f of 0 is -1, we're going to use that, and that the derivative of f is that function. Okay, so the first part is asking about f. We're not going to use g at all right now. And so we want to find the x-coordinate of the critical point of f, and then we're going to classify each critical point as the location of a relative max or relative min, and we're going to justify. This is asking us to do a lot of things in one problem, but that's okay. Okay, so this is the derivative, and so we want to know when that derivative is either 0 or undefined. So because it's in factored form, you could set each factor equal to 0. Is e to the x ever going to be 0? No. So we're not going to worry about that. It's not going to give us a critical number. This other one we need to worry about a little bit. So we'll solve it for x. Don't forget you take the positive and negative square root. So we have two critical points, the square root of 5 over 2 and negative square root of 5 over 2. That's just the first part. We have more things. So we want to classify these as relative min or max. So this is where we're going to do the number line. And we're going to test points. So in between, I'm definitely going to test f prime of 0. So this one is non-calculator. So the first one is going to be calculator. This one is non-calculator. So we don't really know what the square root of 5 over 2 is, but can we know for sure a number that is smaller than the negative square root of 5 over 2? Like what number do you know for sure is smaller than that? Yeah. So negative 3 would be the negative square root of 36 over 2. So that's definitely smaller. And so 3 here, they're good numbers to plug in. All right, so if I'm plugging them in, e to the x is always going to be positive. There's nothing you can raise e to and ever make it negative, so we're fine there.
This is plugged into the original.
This is plugged into the first derivative here, yeah. All right, so if I square negative 3 and subtract 5/4 from it, what do you think, positive or negative? Positive. What about squaring 0 and subtracting 5/4 from it? Negative. And then 3 and negative 3 is going to be the same. Alright, so if you guys, when we first learned this, I feel like you did a lot of this increasing, decreasing little arrows. You can do that if you want. But when we do our justification, it all goes back to if that first derivative is positive or negative. So where is there going to be a relative maximum? What x value?
Negative should
Yes. Now your sign chart that we did here, it is good for work. It doesn't count as your justification. So we have to tell why this is true. And the reason why is because f prime changes from positive to negative at that point. If you want to say that, or you could say there, or you could say at x equals negative square root of 5 over 2. Right, and then we have a relative minimum at the other one, the other critical number. I'll definitely try to give you guys more space when you take your test. All right, and then B. Is everyone good? All right, so B, we're still talking about f. So we're going to find all the values of x at which the graph of f has a point of inflection, and then give the reason for your answers. So for point of inflection, what do we need? Second derivative. All right, now this one, it feels like it might be difficult, but one of the things we're finding the derivative of is e to the x, and that's always just e to the x. So this is, I don't think this is going to be too terrible. So we're going to do the product rule, where we're going to leave x squared minus 5/4 alone, and multiply by the derivative of e to the x, which is just e to the x. And then plus, we're going to leave e to the x alone, and multiply by the derivative of x squared minus 5/4, which is just 2x.
Oh, I love when it works out like that.
Now, I don't know if you're going to end up loving this a ton, Kina.
Oh.
I hope you do. But to figure out what we need on this second derivative is when this second derivative is equal to 0, because that's where it's a potential point of inflection. And so to get that, we're going to have to factor out e to the x, because they both have it. So we're looking at what's in front of the plus and what's after the plus. What's in front of the plus has an e to the x, and so does what's after. So when I factor that out, if it doesn't freak you out too much, I'm going to write it in descending order. All right, so look at that green. Make sure that green makes sense. Oh, that's weird. All right, is e to the x ever going to be 0?
No.
Now there's probably some weird way to factor this, where that's a fraction. It might not even be that weird. But I don't want to do it that way, because I'm going to multiply 3 by 4 to get rid of the fraction. If you feel like you can factor it the way it is, try it. Maybe you can.
It makes me want to cry trying to factor that.
With the 5/4?
Because that's like 1 and 1/4.
Mm-hmm. Yeah, I just figured it out. But let's do it the way that makes a little bit more sense. Now, I know you guys don't like factoring when there's a 4 in the front. Have I ever taught you about the Prizer rule of 4? Okay, Miss Prizer was a teacher that was here whenever I first started teaching, and she told me this. And so if this is a 4, to get 4x squared, it's either going to be 2x and 2x, or it's going to be 4x and x. And the way that you know for sure which it's going to be is you look at this. So if this is a 4 and this is even, it has to be 2x and 2x. If this is a 4 and it's odd, it's going to be 4x and 1. So that will always work for 4. I don't know any rules for other ones, but it'll save you a little bit of time. And then the only way to get 5, what do y'all think? There's 1 and 5. Our signs are going to be different, so we have to figure out like where to put the plus and where to put the minus. Yeah, plus is going to go with the 5, so we can get the 8. So that does end up being 10 minus 2, which is 8. All right, guys.
If it's asking for the point of inflection,
Mhm.
and we've already found like the critical points of the derivative, like
Mhm.
use those maximums.
Well, because the point of inflection is a maximum of the derivative,
Yeah.
we didn't find the maximum of the derivative, we found the maximum of f. So this gives you the relative maximum of f.
But would that be the same thing?
Oh, whenever, are you talking about
Yeah.
plugging in here?
Yeah. 'Cause wouldn't it just be the same?
Well, these are different numbers. So what makes the second derivative? Yeah, let's call it the right thing. What makes the second derivative negative is what makes the second derivative 0 potential points of inflection? Did it confuse you because I didn't have 2 little marks right there? Okay. What makes the first derivative 0 is potential relative maximum min of the original. So we have 2 different sets of critical numbers. I understand what you're saying. Let me finish this problem and then I think I can clear it up. Okay, so we're going to plug in some values. We're going to do -3, we're going to do 0, we're going to do 1. We can plug them into factors if you want to. I think that's probably going to be the easiest way here. Except for 0. 0, when you put in 0, you're obviously going to get negative. All right, so this is the second derivative in positive and negative. So if the second derivative changes from positive to negative, it means that the original function f is changing from concave up to concave down, which is going to be a point of inflection. And then when the second derivative changes from negative to positive, concave up, down to concave up. I'm going to abbreviate. On the real test, don't abbreviate, please. We're just running out of time and room. Change its sign. I want to go back to what Jonathan was saying as soon as you guys get finished writing that down. Little c is important. Okay. This second derivative actually tells when the first derivative is increasing and decreasing. And so the first derivative would be increasing, decreasing, which would make it, the first derivative, have a relative max there. And then the first derivative changes from decreasing to increasing. So that matches up with the point of inflection.
Could you have done like set this derivative to 0 on critical points and then figured out what maximums were, maximums and minimums were?
That is kind of what we did. So the first, when you take the derivative, this is the oh my gosh, my notation is terrible. I'm really sorry, y'all. We're plugging those into the second derivative. When the second derivative is positive, the first derivative is increasing. Okay, C is a super important one. So you can, I have posted, I'm about to. If I haven't already, I'm going to post the answers on C. And so, sorry, I really thought I'd get more done today than I did.